Am I okay to go?
Yep, here we go.
Before I start, this is something that I think I'm pretty sure you guys talked about earlier, but we're supposed to kind of talk about this. And I know you guys are pretty familiar with it, but especially in high school classes for Project Lead the Way, the whole design process is pretty important. So please keep that in mind. Yeah, you guys already know, we started our projects with, the method that we used, I guess, was just, thinking of things that I love it when, or I hate it when, and thinking of things to fill in those provisos. And that's just a good method. There's plenty of other methods to brainstorm, and some people can kind of just spontaneously, intuit ideas. So, but yeah, this is a good method as well. So I came up with several. The main one for me, actually, I play soccer here, and I unfortunately had a bad injury the day before regionals, and I had to keep playing on the injury, but it was very, very painful, and it took a long time to heal from. So it was an ankle roll, or ankle eversion. That's what it's called. Inversion would be like my fist is like my ankle. Inversion is rolling. Well, would be eversion when the side of your. So I don't know if everybody can see, but if your ankle rolls like that, that's eversion. If it rolls like that, that's inversion. And I everted my ankle. So I wanted to create some kind of device that would prevent the rolling of an ankle, because after that, I rolled it like several times in a row. It's very painful. Came up with a problem statement. Roughly 9 million people worldwide are subjected to ankle-related injuries each year. Forgot to mention, this is after I did some research and everything. So specifically, they were with basketball, more or less. And that's pretty typical, because when you're going at fast speeds and then you kind of stop abruptly, that's when you can have ankle eversion. And traditional ankle braces for ankle support limit ankle mobility and are often bulky, large, and expensive, very expensive actually. So I started doing more research into existing devices. This is called the, actually I think it says right there, Armor One Ankle Roll Guard. And this is, if I'm remembering correctly, this is the only one that I found. It's the only existing device that I found that addressed ankle eversion. There's actually a video here. I don't know if it's going to be hard to see or not, but I mean, it might be better. I don't know, it's probably not very good quality, but these are just some people playing basketball. I'll try and point. There's one guy with it on. I had a better video of the guy actually like rolling his ankle, but then the device like stopped him from rolling his ankle, so that was good, but I couldn't find it. So, it's this guy over here, I think, when he comes back. You can see a little band on his shoes. So yeah, that's the device. And it's actually a very good device. So yeah, given that, there's already a lot of research into like prosthetics and different devices to help with that, like ankle eversion. So you don't really have product validation if there's already an existing product. You can't just go and build something for the sake of it. It already exists. There's no point. So I had to think of new ideas, and actually Mr. Andy was the one who suggested this next idea to me. It was to create a device which recycles 3D printing filament. And that seemed like a very, very good idea. I hadn't heard of a device that does that yet. Of course, the research, there are a couple devices, but I had my own ideas of how to make a more unique one. As my problem statement, then I did a little more research. Later on, I think I've got some information about surveys and everything about this. But yeah, as discretionary spending on education decreases, public schools and institutions have less federally provided capital to purchase technology technology for the classroom. A large number of civilians are purchasing and using 3D printers than ever before. Larger and 3D printers are now common equipment for high school and post-secondary engineering classes alike. Post-secondary is just college. The average cost of filament is about $45 per order, and making, having the ability to recycle, polymer plastic is better for the environment. So, let's see. I had to revise this a little bit because your problem statement is supposed to, be valid, and with the filament that's usually used for 3D printers, like the stuff that you guys use and I think what we use, that's already biodegradable. It's made from cornstarch. And also, 3D printers, they don't really produce that much waste, so it's not going to have that much of an effect on the environment. So I considered, and also, hold on, I'm not sure if I have this later. Yeah, 1 second. Okay, there it is. This was something that happened midway through my project. There was a group of students who created a device which recycles plastic, and spools it out and makes it into the printer filament. So, like I said, if there's a device that already exists, then you lose your validation. So that was specifically for plastic, polymer plastic. So what I thought is, well, there are several types of printers that print metallic filaments. So I think they usually use aluminum or stainless steel. So I thought I could create one which recycles aluminum and stainless steel into filament for those types of printers. So I went off that, and so we were supposed to get product validation as well. This is a guy I contacted through email. He's from MSOE, the Milwaukee School of Engineering. He was born in India, actually. He sounded Indian. But yeah, I talked to him and he thought it was a great idea. So, began doing research. This is the photo there is just some results I had from my consumer surveys. And for these, I couldn't just send these out to the average person because the average person doesn't own a 3D printer. So I had to find some forums, some different, 3D printing communities, and give them these surveys. And I didn't get a whole lot of answers. I think I only got about 40, and it's better to have 100. And that's just because it's it's more difficult. There aren't as many of these people as you can't. These aren't just the general public. And plus, I don't think as many of them really care about a high school engineering project. They probably have some things that they're working on their own. Oh, yeah, sorry about that. So yeah, then I developed the CRD, created a device which recycles material into 3D printable filaments, specifically for PLA and ABS filament types. That was the first CRD. PLA and ABS are what you guys use, the plastic stuff. But of course, then I changed it to stainless steel and aluminum, while maintaining a cost efficiency of under about $75 to run it, because from the survey results, it was about an average of $75 spent per order on 3D printing filament, for the people who responded at least. So I began brainstorming. I decided to recycle metal, and so obviously you're gonna have to conglomerate it. That's the right word. You're gonna have to melt it down and everything. So electromagnetic induction is something that I thought of. And it's gonna be a little tricky to explain. This is a diagram, but basically you have coils of metal, and then between and you have them hooked up to a large voltage source, and you put an object in between the coils, and it actually heats it. It superheats it. And depending on the voltage and everything, you know, it gets hotter. You have higher voltage and everything. So I was going to use that to melt down instead of like a hot plate or something, you know, built into the device and everything. And I also thought, well, I wanted to have it all automated. That's how it was going to be different from other existing recyclers. It was going to be all automated. So there was going to be some programming I was going to do, and you know, some motors and everything on the end that were going to extrude it on its own and spool it and everything. This was, I was going to mention something here, but I can't remember right now. Apologize for that. Okay, so I should probably go forward a little bit. Okay, yeah, so I went with this. I switched from the first ankle eversion device to this idea, I think, what was it, like a month into first trimester. And I kept going with this. However, when I was going to build this actual device, a lot of problems came up. So specifically, this is a screenshot from, this is some of my circuit design. I'm using an open source circuit software to design the circuit. These are chips, and chips, I don't know what you guys are taught, but they have series of gates on them and whatnot, and it's like, you know, you apply like programming to it, and that was supposed to be for the automation part. But also, you know, if you're using a large voltage source, that's very dangerous, so gotta have something to regulate it. So, yeah, it was designed this circuit, and a lot of issues came up, specifically with resistance, using like voltage resistance. I'm sorry, not voltage, current. It was like, if you don't have enough resistance, it overheats like certain components of, or it would. And there's certain things there's certain objects you can use, I forget what they're called, but they take up some of the heat. But the program was giving me errors because I had too little resistance. And I wasn't able to figure out how to solve that without obviating some of the part later on. Voltage, you have to have a large voltage supply for this, and it was, you know, that was creating problems. I also was not sure how to get that voltage source. You know, this isn't something you can just plug into the wall. I don't know, I couldn't think of something to use for a power source. And also the gate automation, my circuits were having some issues just in like their outputs. They weren't giving the right outputs. Oh yeah, these are some of the things that I was going to have to buy for my project when I built it, and I estimated about $50 to $100 was going to be the price. Let's see. So I wasn't able to build my the actual device. I did a lot of circuit design, and I had planned on building like the initial. Should I keep going, or should we? Okay. The induction device, because that's very easy to build. The problem is just with all the circuitry. So, I was going to say something. Let's go back. Try and jog my memory. Oh yeah. So, trying to think what I was going to say.
I put off changing directions